Good afternoon, I am Mr. Ish. We are looking here at another video, partial fractions decomposition. Very recently I presented this whole concept and topic of decomposing a rational function into its partial fractions. Remember, if you're ever going to go into college and go into calculus classes, especially engineering, you have to know this. There's no way that you can avoid this specific topic. But on the other hand, if you want to just look cool with your friends and you want to learn this technique, might as well. It's an excellent idea, an excellent technique concept to learn. We will look at two questions here and we will get right into them because we are learning the techniques. Remember, I'm presenting you simple examples here. It gets hard, it gets more complex, more complicated, but you start easy and then you slowly go up hard. Our first question we have to decompose is this. Remember, you have a rational function here. Ideally, the order of exponents must be higher in the denominator polynomial than the numerator, and it is. This is ideal classic technique example for PFD, partial fraction decomposition. I like to abbreviate that way. How do you start? Well, you look at the denominator, you factor it out. You have x minus 4 and you will have x plus 1. What do you do then? You counted the number of these factors you have. These are all simple cases, so what you see is what you get. You have two factors here, therefore you must have two items here. One which will borrow each of these specific factors, and you'll always put a letter over here. These are simple reduced factors, therefore you just put simple letters on top. And now you do common denominator, x minus 4, and then you have x plus 1. But don't combine these common denominators, keep them separate and do the fraction algebra. X minus 4 goes in this, x plus 1 times. It attaches with the a plus. And remember, these template items are always in an add format, a sum format. And remember, this template right here, this specific template to form that, to decipher from what you have is the hardest part. Everything after that is relatively easy. And then b into x minus 4. You can, if you want, erase this. I erase it only because I need space. You open this up, you have ax plus a plus bx minus 4b is equal to what? This right here, x. But I have a couple of constants here, so yeah, I might as well put a placeholder, a 0. Look at your linear terms and then look at your constant terms and make your equations. I have ax, bx, x. I just look at the coefficients. A plus b is equal to 1. My other one is the constants. A 4b equals 0. I can say a minus 4b is equal to 0, or you can say a is equal to 4b. This right here is very helpful. If a is equal to 4b, you can put 4b right here. 4b plus b is equal to 1, and then I have b is equal to 1 divided by 5. So I know now b is 1 over 5, and we can put 1 over 5. If a is equal to 4b and b is equal to 1 over 5, then a must be 4 times that, which is 4 over 5. There it is, my a and b terms. See, a and b terms. I can put those items right here in places of a and in places of b. A is equal to 4 over 5, so why don't I just put 4 over 5? B is equal to 1 over 5, so let's do that. You can write this again here in a clean format. 4 divided by 5 into x minus 4 plus 1 divided by 5 into x plus 1. This right here is your decomposed partial fraction. If you were to do all of this common algebras, techniques, manipulation, all of that, you'll end up right over here at this original rational function, and that answer should be right. This here is my question number 2, a rational function. If you're thinking in your mind, why do you have to take a rational function and decompose it into its parts, the partial fractions? There's a reason why you have to do it, but you're not appreciating it right now because you haven't done calculus. When you do calculus, there's a reason why you have to decompose it, because whatever it is that you have to do with a rational function is hard. But when you do that same procedure with the partial fractions, it's much easy. Then you combine it all up to get to your final answer. But that's calculus, you learn that. You just have to learn this in pre-calculus to be able to do it in calculus. Alright, that's how the sequence works. Again, you have a rational function. Before you do anything, simplify your rational function. You can isolate an x from here. In the numerator, you can isolate here an x squared, and you have a 1 plus x, right? You can cancel this out with one of these. You'll essentially convert your entire rational function into this easier form right here. This right here is my factored form, and look, when you're looking at this factored form, you're seeing two factors, therefore you know you will have two template items, one of which is an x, the other is an x plus 1 or 1 plus x, it doesn't matter. On top of this you'll put a, on top of this you'll put b. Again, I'm stressing to you, we're looking at easy examples here because these things are turning out to be easy and straightforward, therefore everything on top is easy and straightforward. Anyhow, common denominator is x and x plus 1, and you just have to manipulate all of this in terms of this fraction. A will hit with x plus 1. b will hit with just the x. You can remove this. Open that up, you'll have ax plus a plus bx is equal to what? It always equals to your simplified numerator, x plus 2. Look at your terms. You have a linear term, linear term, linear term. When I'm talking about linear term, I'm talking about my linear variables. Then I have a constant and a constant. I have a a plus b is equal to 1. The coefficient a here, b, and then 1. A plus b equals 1. That's one linear equation. The other one is just a is equal to 2. If a is equal to 2, then you know b is equal to what? You'll take it on the other side, minus 1. You've determined that. Remember, these systems of linear equations are relatively easy. Now you're looking here in your template, this template. You're going to substitute your a and b values. A was here 2, b here was minus 1, right? Minus 1. This can very well be your answer, or you can clean it up and write your answer as is 2 over x minus 1 over x plus 1. This right here is your decomposed partial fractions of this rational function right here. What you have to do with this in calculus is hard, but what you have to do with this in calculus is very easy, and this answer is right. And I say we will be looking at more of these videos, partial fraction decomposition, because we have to essentially increase the complexity of this rational function, but we don't have to do it right away or fast. We can do it over a period of time. Thank you for watching. Have a nice day.